Welcome. In this video, I will be going over an application of the chain rule. The prey population P in thousands depends on predator count R in hundreds. Predator count depends on the protected habitat area H in kilometers squared. So at H equals 250, that is at a protected habitat area of 250 kilometers squared, dP over dr is equal to negative 0.9, and this is the change of prey population with respect to predator count. And dr over dh is 0.04. So this is the change in predator count with respect to protected habitat area. Compute and interpret dP over dh. Now in words, what is this? This is the change in prey population with respect to the change in protected habitat. Okay, now those of you in my class should have seen one similar example, and in that example I went through the process of our usual function notation where we have, say, a composition of functions, and I kind of used this notation and related it to this Leibniz notation right here. I'm not going to do that this time since I'm assuming you already watched the previous video and have a better handle on the notation. That said, we still need to get a handle on which thing is a function of which other thing. So let's start with prey population P. So we're told it depends on predator count. So P is a function of R. Okay, well, what does that tell me? That tells me P of R is how I would write out this function. Now let's take a look at R. R is the predator count, and that depends on protected habitat area. So R is a function of H. So we'd write R of H. Okay? Now, as one function, if you are curious, it would be PR of H with derivative dP over dH, which is our goal. Okay, so dP over dH is going to equal the derivative of P with respect to R times the derivative of the inner function, which is R, again here. So dr over dH. Now, what are all these values? dP over dr is right here. Okay, we were told that that's equal to negative 0.9. And that looks like an A, so let me make that look more like a 9. There we go. And then, of course, we were told that dr over dh here is equal to 0.04. All right, so what does that give us? This tells us dP over dH is equal to negative 0.036, and this is the prey population, the change in prey population, with respect to protected habitat area. And we're told that the prey population is in thousands, so let's convert this. So prey population is in thousands. So we have negative 0.036 times 1,000 is equal to negative 36. And oopsies, excuse me, I was just trying to get this all together as a little aside there. Now, what does this all mean more importantly? Well, at 250 kilometers squared, and again, we were given this, of protected habitat, adding one more square kilometer of protected habitat reduces the prey population by 36. So it might seem counterintuitive to think, oh no, if you were, doing some sort of research or trying to figure out how to protect species, you'd be like, oh no, we're adding, protected habitat and it's reducing like, the number of, say, bunnies, but maybe that's because there's more wolves eating them, right? So the reduction in prey is likely just due to an increase in the predator population. All right, so there you have it. Please keep calm and math on.